this video on YouTube. I'm Terry, ID number 15963. Me and my friends from CCB 3062, Unit Operation Laboratory 2, May 2014, are going to present our last experiment, which is CFE, stands for Climbing Film Evaporator. We are from group B19, which consists of Ummu Athirah, Goh Wei Min, me, and Shaavesh. I'll be doing on objective and theory part. For this particular experiment, we are only doing part A. There is two parts in this experiment, but we're only doing part A. For part A, the objective of the experiment is to determine whether the different amount of pressure affect the volume of evaporate, condensate, and concentrate using grape juice, simulated with KMnO4, which is potassium manganate and water mixture. For the theory part, first, what is evaporation? Evaporation is a process where the vapor from the boiling point solution is removed and a more concentrated solution remains. In a simple language, evaporation is removal of water from a boiling aqueous solution in this experiment. An evaporator is used to carry out this evaporation process. In this experiment, we use CFE, climbing film evaporator, instead of a normal evaporator. Why? Why is CFE so different? CFE is a special type of evaporator because it has high heat transfer coefficient and a short residence time for the solution being evaporated. It is operated under vacuum and also operate as either a batch or a continuous process. Climbing film evaporator can actually demonstrate the following studies. First, influence of vacuum levels on evaporation rate. Second, influence of steam flow rate on evaporation rate. Third, influence of feed flow rate on evaporation rate. Lastly, influence of evaporation time on evaporation rate. Basically, CFE are being widely used in industrial area. Why is that so? This is because it is ideal for concentrating heat-sensitive materials. It is most commonly used to concentrate fruit juices, black liquor in the craft pulping, dairy product, and lastly, desalination applications. And with this, I end my presentation and I pass on to Ummu Athirah for her part. Thank you.
I'm Ummu Athirah, and I will be explaining about how to conduct the climbing film evaporator.
Methodology. Firstly, we have to prepare 20 liters of potassium manganate solution at calibrated standard concentration 0.00477 mole. The refractive index for this solution is 1.33449. This solution is already prepared by the lab technician, but the students must recheck the concentration. Then, we move to the next step, which is to conduct the experiment. This is the figure of the climbing film evaporator. I'll be further explaining the parts as we go on. First, we have to open the valve for main cooling water supply. Subsequently, turn on cooling water valve to allow flow into the condenser. Ensure that circulating cooling water flow rate is 6 liters per minute. Before the experiment is started, ensure that V7, V9, V11, V12 and V14 are closed. Open valve V2, V3 and V5, while close valve V1, V4 and V6. Turn on the feed pump in order to circulate potassium manganate solution and wait until the solution is homogeneous. Collect a sample from a feed tank by using V1 and measure its corresponding refractive index. Record this value. Now, with the feed pump turned on, open V6 in order to set the level of potassium manganate to 25 cm level. Measure the volume of potassium manganate solution inside the column by transferring into volumetric cylinder by opening valve 14. Repeat the column filling process by opening V6 and set the level to 25 cm again. Starting at atmospheric pressure, turn on the steam supply. Before the steam is transferred, the purge valve is open and the main steam valve and the steam supply valve are closed. Very carefully, open the main steam valve to half open. When opening this valve and closing of this valve, start the stopwatch timing. When the first bubble appears, time taken will be recorded, and the reading of the steam flow rate and pressure will be recorded. After 20 minutes, close the steam supply valve and open the steam purge valve at the same time. No need to close the main steam valve because the main steam valve will obtain the steam flow rate and pressure for the next running. Collect the samples of evaporator using V14 and the sample of concentrate and condensate using V12. Concentrate and condensate samples may be taken afterward, but the evaporator sample have to wait for about 15 minutes. The first sample taken is condensate. Just easily open valve 12. The second sample taken is concentrate. To take the sample, you have to use transfer pump. First, we have to close valve 12 and open valve 7 to let the liquid flow to the inlet transfer pump, then close V7 and open V9. Turn on the vacuum pump and the liquid will be transferred to the condensate receiver tank 2. After all the liquid has been transferred, close V9 and open V12 to collect the samples. Redo the vacuuming if the liquid is still remaining in the inlet transfer pump. After 15 minutes, you can collect the evaporator sample. Just easily open V14. Measure all volume and record the refractive index for all samples taken. Make sure to return all the samples into the feed tank. Redo the experiment by using different value of pressure. In our experiment, we use -200 and -400 mm mercury.
Good afternoon everyone. My name is Goh Wei Min and my ID is 16169. I'm going to present to you about the results and the discussion of climbing film evaporator. As mentioned before by my groupmate Terry, evaporation is a process whereby the liquid is transferred into the gaseous phase under constrained pressure after its boiling point. Heat is being transferred into the solution where what we use in this experiment is potassium permanganate. It will transfer the heat into the solution and remove the water content in the solution to make it into a more concentrated solution. In this experiment, the solutions of potassium permanganate KMnO4 is earlier prepared by the technician and we only need to measure its refractive index when we are doing the lab. Why we need to record its refractive index? It is because the refractive index is related to the concentration as is shown in this graph. The potassium permanganate, the refractive index is plotted like this and will obtain a linear equation where y is equals to 20.837x minus 27.802. With this, in this experiment that we get, the result that we obtain is as shown in this table. We'll measure first we'll state the thing with the level of potassium manganate at 25 cm, and we'll close it to the pressure, atmospheric pressure, and we'll record the volume and refractive index of evaporate, concentration, drip, and condensate. After this, after each experiment is done, we'll do it with different pressure, which is the at atmospheric pressure, negative 200 milliliter mercury and negative 400. Each of the result is recorded in this table. We will then calculate the concentration of the solution by using this graph again with this equation by plotting the refractive index into the x. By this, we will obtain the concentrate of the solution. After all the calculation we have done, we will plot a graph to show the relationship of the pressure and the time for the first bubble to appear. As what we have said before, the aim of this experiment is to investigate the effect of the pressure on the climbing film evaporator. Theoretically, we know that the climbing film evaporator is designed to operate under high pressure and have a low cost. We have conducted this experiment under 3 pressure, which is at the atmospheric pressure at under negative 200 millimeter of mercury and under 400 millimeter of mercury. As you can see, the graph we obtained look like this. With this, we can observe that as the pressure going higher, the time for the first bubble to appear is lower. You can see this. And the time taken for the potassium permanganate to boil is faster also. Why is this so? This is because the boiling point of the solution decreases as we increase the pressure. At high pressure, the energy needed to overcome the bond to break it will be lesser. Thus, the time required to show the first bubble and for the solution to boil is decreased also.
I'm Shaavesh, my ID is 16703, and I'll be talking about the error, recommendation, and the conclusion for this experiment. In the error, there were several errors to be talked about and highlighted in this experiment, but some of it is this parallax error and an inconsistency of pressure drop in the pump. Parallax error. The eye level is not placed properly when you are recording the volume of liquid, and this might affect our results in many ways. In the inconsistency of pressure drop in the pump, the pressure reading tends to fluctuate a lot, and when this happens, we need to adjust the pressure manually, and it will affect the time for the experiment. Okay. In the recommendation part, a tool should be provided for the students so that they could measure the height appropriately. And another thing, when measuring the liquid volume, it's best that a white paper is placed behind the cylinder so that students could get better reading to be exact for the experiment. Not only that, the pump as well should undergo regular maintenance so that a better reading can be obtained. Not only that, it is advisable to use the digital reading pump compared to the analog reading pump because it produces a better reading. Okay, coming to my conclusion. The manipulated variables for this experiment is the vacuum levels, fluid flow rate, and the evaporation time. The pressure decreases, the time for the first bubble and the boiling point as well decreases. And what I want to say in conclusion is, all factors should be measured in order to attain absolute evaporation rates. That's all from me. Thank you.